Hello there guys, welcome back to another epic Inexorable maths video. In this video we're looking at proving the double angle formulae using the compound angle or the addition formulae. Some people call it the compound angle, some people call it the addition. We're going to look at what those are in a second, but first of all, what are the double angle formulae? They're what we want to prove in this video. So let's take a quick look at that. So guys, these are the double angle formulae. We see that we have sine 2a, cos 2a, tan 2a. And what we can do, basically what these double angle formulae do, is they let you write the sine, cosine or tangent of some angle in terms of half of its angle. So if you have, for example, sine of 90 degrees, you could say A is 45 because that's 2 times 45. So you could write sine of 90 degrees as 2 cos 45 times sine 45, if we just take the top one, for example. So it's quite useful. It's useful for lots of reasons. It's particularly useful in integration for integrating sine squared and cos squared because they're quite difficult to integrate. But we'll look at that in the future, guys. It's okay. These are quite useful in and of themselves for various different reasons. Really, really useful actually. But you can see what they are there. So one thing to mention is that cos has actually got 3 double angle formulas. That's like 6 angles. No, I'm just joking. But it does have 3 double angle formulae. It has 2 cos squared a minus 1, 1 minus 2 squared a, and cos squared a minus sine squared a. They're all the exact same thing. Even the seagulls want to get involved, guys. It's kind of crazy. But how do we get these? Where do they come from? There's lots of ways to prove them. You can use complex numbers, or you can use the addition / compound angle formulae, whatever you like to call them, in order to prove them. And they're really not that bad to prove if you already know the addition and compound angle formulae. If you don't know how to derive the addition / compound angle formulae, there is a link in the description below where I'm going to prove it using complex numbers. I'll also make another video in the future proving this without the addition / compound angle formulae. We still need complex numbers though, which is, if you like complex numbers, that's cool. Anyways, let's get straight on with the video. So, as a quick reminder, or actually an introduction if you haven't seen these before, these are the compound angle formulae. So sine A plus or minus B is actually the same thing as sine A cos B plus or minus sine B cos A. And obviously you can see them for yourselves. They're just these. And these, again, they come from complex numbers. You can prove them geometrically, but it's a bit of a pain. They're quite interesting. But you can see that these things, well, they have 2 angles, but we have an A and a B. A and B are angles. But what if they were just the same angle? And this is how you get the double angle formulae. If B, in these equations, was just equal to A, then we could say, well, let B equal A, and we could do some rearranging. And that's exactly what we're going to do. So those are the addition formulae or the compound angle formulae, and we're going to use them right now. Okay, so let's prove the first one. This is the double angle formula for sine 2A. This is the addition or compound angle formula for sine A plus B. The way that we get the double angle is by replacing B with another A. Basically saying that A and B are the same angle. That means that I can say that sine of A plus, well, B I'm just going to say is the same as A. So sine A plus A is just sine A cos A plus sine A cos A, replacing the B's with A's and leaving the original A's how they are. And then, if you just simplify this, you get sine A plus A, that's just sine 2A. This is identical, of course, to sine A cos A plus another sine A cos A, that's 2 sine A cos A. And that's actually the addition, the double angle for sine 2A. There it is right there in all its glory. Really, really, really useful. Really useful stuff. Lovely. Okay, on to cos. Okay, this is the one for cos. So this is the compound angle formula for cos. Cos A plus B is just equal to cos A cos B minus sine A sine B. So if we do the same thing as last time, we just get cos of A plus A, letting B be equal to A. We end up with cos A times another cos A, wonder what that will be, minus sine A times another sine A. Also wonder what that will be. Well, of course, that's just going to be equal to cos squared A minus sine squared A, just like that. And that on the left-hand side is equal to cos 2a, because a plus a is 2a. This is the kind of main one for cos, but sometimes this is not particularly useful. We would rather write it in a different way because we have a cos squared and a sine squared in there. It's not that nice. So you can replace it with two equivalent identities. This is why cos is probably the most complicated one, because it's got two more. But not to fear, guys. The way that we get the other two is very simple. We have to start with this anyway. But we need to use the very, very, very famous equation that cos squared of any angle plus sine squared of any angle is always equal to the number 1. Always, in any case. So we're going to use this. This just comes from Pythagoras. I'll make a video proving this one in the future. It's very, very, very important. One of the most important formulas in trigonometry. We use this essentially to replace individually, in one case the cos squared and in the other the sine squared. I'll show you that. So first of all, let's replace the sine squared. So cos 2a is identical to, I'm going to write cos squared a again, but this time I'm going to replace sine squared a. If I take this equation and I make sine squared the subject, I will get that sine squared a is 1 minus cos squared a. Okay, so I'm going to replace sine squared a with 1 minus cos squared a. They're the same thing. Sine squared is the same as 1 minus cos squared. And from here, you can see that cos 2a is identical to, well, cos squared a minus 1, and then there's also a plus another cos squared a because there's a minus and a minus there. So we end up with 2 cos squared a minus 1. And this is the next one for cos. This one's really, really useful. Integration, stuff like that. Okay, we want the other one though. There's another. How do we get that, I wonder? Well, of course, we do the same thing, but if I go back up actually, we can see that this was our sort of initial one. This time, let's just replace cos squared with 1 minus sine squared, because again, cos squared is just 1 minus sine squared. If you imagine taking sine squared away from both sides, you get cos squared is 1 minus sine squared. So if you do that, you end up with cos 2a, which was originally cos squared minus sine squared, but cos squared is 1 minus sine squared. And then we need to take away another sine squared because it's cos squared minus sine squared. And then that will be equal to 1 minus 2 sine squared a. This is the next one for cos 2a. So there we go. There's all three. They're all useful in their own right. So cos 2a is 1 minus sine squared. It's 2 cos squared minus 1. And it's also cos squared minus sine squared. Cool. On to the last one, tan. Okay, this is the compound angle formula for tan. All we're going to do is just like before, we're going to replace the b with an a. We're going to say b is the same angle as a. That means that tan a plus a is equal to nothing more than tan a plus another tan a over 1 minus tan a multiplied by tan a. Just like that. Bit of a mess there, but there it is. Okay, taking that, we then get that tan a plus a, that's just 2a, is identical to, well, tan a times, tan a plus tan a, I mean, is 2 tan a. And this is over 1 minus tan a multiplied by tan a. That's 1 minus tan squared a. And that's actually all there is to it. That's it. That's the one for tan. Tan 2a is just 2 tan a over 1 minus tan squared a. Again, this one arguably is one of the most important ones for various reasons. There's the tan half angle formulae that are based around all of these. But they're really important stuff. Really important stuff, guys. So that's the one for tan. And in total, there are, what is that, 5 of them. There's one for sine, there's one for tan, and there's 3 for cos. They're all really, really useful. They all come from the addition / compound angle formulae. And they're all really, 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 really useful for loads of things. Integration, proofs, all sorts of stuff. So guys, if you found that video useful, please like, subscribe, share with your friends and family. And I'll see you in the next video. Cheers.